I was gonna end up outside the classroom. Hey, no,
don't grab it. Don't grab it.
no, there's
Okay, if you guys can turn to page 16. If you guys look on the board, those are the formulas that we're going to be responsible for the quiz. So the quiz will be on Wednesday. Okay, quiz is Wednesday. We'll go over most of the notes today. Be able to start going over quiz review, hopefully end of class today, and then quiz review tomorrow, and then quiz on Wednesday. Okay, so today we're going to be focusing on formulas like number 5 and 6, dot product and angle between vectors. We've done everything up to this point. Magnitude is just Pythagorean theorem. Direction is just tangent. Component form is just subtracting the x's and y's to get into horizontal and vertical displacement. And then number 4, that rule there is just basically the result of drawing a right triangle and using SOHCAHTOA. But we have it in that form just to make it easier, so you don't have to draw the triangle. But if you want to draw the triangle, you don't have to memorize that formula for with component form. But okay, let's start with dot product. So dot product is where we're multiplying vectors together, and when you multiply vectors together, it's similar to what we did with adding vectors. It's just that now you're going to be multiplying the like terms and then adding the remaining. So if I'm trying to multiply vectors u and v together using dot product, I just do a1 times a2. So the horizontal components I multiply together, plus I do the same thing with the vertical components, b1 times b2. Okay, so that's dot product. Dot product, you're literally going to see a dot between the two vectors there. So number 1 says find the dot product between the following pairs of vectors. So I'm just going to find the dot product between vectors u and v. So practice writing the notation. It's vector v dot v. Sorry, vector u dot vector v. So we're just going to identify the horizontal components, multiply those together, and then identify the vertical components, multiply those together. At any time, if you want to plug into your calculator, you're welcome to do that. What is this equal to? 0, right? There's something special about 0. We'll talk about that later. But right now, that's just the dot product. Now, number 2. Number 2, this is written in unit vectors, but we can write it quickly in component form and then use this rule. So we can say that vector A is just 2, 5. And then vector B is just 8, -4. So now we're going to find the dot product of vectors A and B. Okay. Combine the horizontal components together, and then separately combine the vertical components together. And then you just put a plus sign in between. -20 plus 16 Okay. Angle between vectors. There's a whole proof behind this, but I'm just going to share the formula, and then we're just going to practice using the formula. Okay. So the angle between vectors. So let's say you want to find that angle between those two vectors. Okay. And the way you go about doing this, don't worry about vector A and vector B. We're just going to jump directly to the formula here. Okay. So cosine of theta is equal to vectors A times the dot product of vectors A and B divided by the magnitudes of vector A times the magnitude of vector B. So we learned from last week, magnitude is just Pythagorean theorem and then square roots, right? So we're going to find the magnitude of vector A. So that's square root of A squared plus B squared, right? Whatever the horizontal components are for that vector, multiplied by the magnitude of vector B. Okay, so there's a lot going on, but we're just imagining just combining a couple of problems together into one. Okay, so let's practice how finding angles between two vectors. And let's start with this example. So I'm going to move this example up to the top so we can use the space for that. Okay, so here's the example. I'm going to rewrite the example from below. So let's say we have vector C. And vector D. Okay, so right now I'm going to split everything up into its individual parts. But hopefully once we get comfortable, we can just put it all into this formula all at once without having to do all the parts separate. But right now I just want to kind of show that really it's just a combination of multiple procedures. So let's adapt the formula. Okay, so the formula is going to be this: cosine of theta equals the dot product of vector C times and vector D divided by the magnitude of vector C times the magnitude of vector D. Okay, so right now I'm just going to gather all the information separately, but hopefully after we do this once, we can kind of just put it all together rather than using a lot of space. So let's start off with vector C, dot product of vector C and D. How do we do that? So we're just going to kind of gather some information separately and put it back into the formula. So that's just the formula from above, right? Horizontal component plus the vertical components together. Okay, so how will we get this result? -5 times 4 plus 8 times -2, okay? -20 minus 16, -36, okay? We'll set that off to the side. We'll come back to it because we need it for this top portion. Okay. Vector, the magnitude of vector C, that's just Pythagorean theorem, right? Square root of A squared plus B squared. And just understand that you can put everything, you can put all the negatives inside, but everything's being squared here, so really we can ignore the negatives because everything will just become positive. (25 plus 4 is 29). Okay. Okay, so now there's this last piece that we need, the magnitude of vector D. Square root of A squared plus B squared. So that's 16 plus 64 gives us 80, okay? So piece by piece, we're just putting it all together here. So this numerator is going to be -36. You got a root 29, you got a root 80. And we're going to go to the calculator to see if it'll help us get it down to an angle measure. Okay, so negative 36 is the numerator. Denominator is the root 29 and the root 80. Okay, so use your calculator. Let's get that right side cleaned up as much as we can. Okay, negative 0.747. Okay, so how can I solve for theta? Inverse, yeah. Make sure you're in degree mode. Under 38.37 degrees. So it's a lot of pieces, but you're just taking operations that you've learned and just putting it all together on the right side. So the dot product goes up top, magnitude of vector C, and then separately magnitude of vector D, and then multiply those together. So you're going to end up with three numbers that you're going to divide and multiply. So dot product goes above, magnitude goes below. Enter all that into your calculator, get a fractional value, and then do inverse cosine. Okay, so I have a definition here, orthogonal vectors. Orthogonal is another word for perpendicular. So that just means two vectors intersect at a 90-degree angle. If and only if their dot product is 0. So whenever you see two vectors that have a dot product of 0, you know that those two vectors are 90 degrees in relation to each other. So for instance, number 1, you see that vector u, dot product of vector u and v is 0. So this indicates that u and v are perpendicular. Or orthogonal. We can put that note above now that we know what that 0 signifies.
You go back down to the.
Sure. Okay, orthogonal vectors are two vectors that two vectors are orthogonal, or another word, perpendicular, if and only if their dot product is equal to 0. Okay, so this next example says create a non-zero vector that is orthogonal to vector m. So I'm just going to say, well, I know another vector will have to pair with it in the sense that is going to be -4 times some vector or some horizontal component plus 2 times some vertical component, and that must be equal to 0. So there's a lot of possibilities here. Can you guys think of two numbers here that will allow this result to give us 0? 2 and 4, right? So there's infinite numbers of options. So 2 and 4 works, 1 and 2 works, -3 and -6 works. Right? So basically, any vector that you can come up with, you can always find a vector that will allow for things to cancel out to be 0. Basically, infinitely many possibilities. Okay, parallel vectors. Okay, vectors are parallel. If the dot product is equal to the product of their magnitudes. So parallel vectors is when your theta measure is 0 or 180 degrees. So basically what this means is that this number is the same as the result of these numbers here, or the product of that number. So if the numerator and denominator are equal to each other, that basically means you're getting 1, and cosine of 0 is equal to 1. So if your angle measure are the same as each other, or the degree between the angles are the same, then they're basically dealing with parallel vectors. So basically that's just what it means. It means that the numerator, the dot product, is equal to, so this is 20 and this is 20, then we know we're dealing with parallel vectors. Okay, determine the angle between the following pairs of vectors. I don't think we have enough room to do all three. Let's just do the first one, and we can use this whole space for it. Okay. So we'll just use the formula like above, right? Cosine of theta equals dot product of the two vectors divided by the product of their magnitudes. But I'm going to try to do it all under one formula rather than using all the space. Okay, so see if you can adapt to that. Okay, so cosine theta equals, okay, let's do the dot product above. So that means you're going to pair the components together. So -2 times -6 plus 5 times 15. Okay, we'll figure that out later. And then the below, we have two Pythagorean theorem things going on here, right? Two Pythagorean theorem calculations here. One is magnitude for vector, for the first vector, and then second is the magnitude for vector b. So I'm going to just put all this messiness here. This is really square root of 2 squared plus 5 squared. And then separately, I'll do the Pythagorean theorem for the second vector. Square root of 6 squared plus 15 squared. Notice I'm leaving the negatives out of it because I know that the squared operation will just wipe out the negatives. So I'm just always I only care about the positive. Now, when you do dot product, keep track of your negatives, okay? But when you're dealing with that Pythagorean theorem, all that negative will just go away once you're squaring each of the numbers. So that's why I just ignore the negatives. Okay. Right, and then now we're just going to try to clean up the numbers as best as we can before we start plugging into the calculator. So this is 12 plus, I got 87, double check my work. This is 4 plus 25, so that's root 29. And this is 225 plus 36. Okay, make the calculator do all that mess of an operation and then do inverse cosine to get to your theta measure. Do you guys get 12 degrees? Wait a second. Oh, did you guys get 87 over 87? Okay, sorry about that. Yeah. Okay, did you guys get 0? Okay, so this tells us, right? So this is an example of parallel vectors. You see how the numerator and denominator ends up being the same number? So that indicates that we're going to be getting a 0 degree. If we're getting 0 degree, we're getting parallel vectors. Sorry about that. So off to the side, we can say, okay, this is an example of parallel vectors here. Okay, page 17, we're just going to practice doing dot product. So this should be pretty easy, page 17. So let's just do the odds, 1, 3, 5, 7, 9. Does anybody still need this page? Okay, so start with number 1. If you want, if you can use the space below, it shouldn't take a whole lot of space, but if you want to use the space below, you can. So just do dot product for the 5 problems there. Number 9, it looks messy with word problems, but just identify, just do the same thing that you did for 1, 3, 5, 7. So multiply the horizontal components together, multiply the vertical components together, and then add the results. Okay, so page 17, try number 1. And then you also want to state whether it's orthogonal or not. So that means if the vectors are perpendicular to each other. So if you get a number other than 0, then it's not going to be perpendicular. So just say not orthogonal. So this is, look at number 1. Look at how I worked out number 1. See if you can try that for the others. Okay, page 17. And we're just doing the odds, okay? 1, 3, 5, 7, 9. It should go pretty quick. Any questions with 1? Okay. Number 3. Okay, if you want to move ahead, next page, we're just going to do 20 through 24. So 20, 21, 22, 23, 24. And this is practicing going through that angle formula, cosine theta equals dot product of uv divided by magnitude of u and v. So 20 through 24 on the next page if you're trying to work ahead. So here's number 5. Okay, so 20 through 24 on page 18. So 20 through 24, try number 20. So on page 18, we're just using this formula here, angle between vectors. Okay, is everybody good with this page? Okay, just making sure that you're on the right, going on the right track here. Here's my work for number 20. Okay, I do want to walk around, make sure that that you guys are comfortable with these types of problems, because it is a little bit on the heavy side in terms of a lot of things coming together. So let me see how you guys do with 21 to 24 as well. Yeah. Right, so I did Pythagorean theorem. So this is the max, so I can work out this. So it's going to be -9 and 0. So the magnitude of vector u is going to be the square root of. So this is Pythagorean theorem. I'm doing a little bit of a shortcut. I'm not doing the squared. I'm finding the values just without showing all the squared terms, but you can if you like. I'm not checking just yet. I just wanted to make sure that you guys know. Because I'm going to see if I can, if we have time, I'd like to start some of the quiz review. Everybody good with number 20? Okay, here's 21. Again, when you're dealing with Pythagorean theorem, if you want to completely ignore the negatives, I'm fine with that, because you know the negatives will just wash out because of the squared. So if you want to just ignore the negatives, don't ignore the negatives for the numerator, but you can ignore the negatives for the denominator because of the exponent of exponent 2. Any issues with 21? For 22, once you're ready. Any questions? 122. Okay, here's 23. Hoping that after you guys have done a couple of these, you feel more comfortable with just how these numbers come together and how the formula gets put together. '24 will be the last one on this page. Okay, is everybody still looking at 23? Okay, 24? And if you guys are finishing up, I'd like to start the quiz review, but I like to start with the hardest ones first, because I know that the easy ones you guys probably won't. We can just go through that tomorrow. But I want to start with the ones that feels most challenging, so we kind of just have more time with it. So on page 20, we're going to try to get through 12, 13, and 14. So read those problems and see if any of those formulas can be of use. So go ahead and read page 20, number 12. See if you can make sense of that.
It says forward. It says forward. What's the number beside it? Right in front of it.
Oh, 49.
That's a 9. Okay.
Yeah, 49 and 36. 3 squared and 5 squared. Okay, any question with 24? Everybody good? Okay, so page 20. Quiz review starts on page 19, but I think these are easier ones. I want to kind of go to the more challenging ones here. Number 12, I think it's harder than it looks. I'm sorry, it's easier than it looks. Easier than it looks. Number 12, it says boat is traveling west at 25 miles per hour. The current is moving south at 3 miles per hour. These two sentences, we can create vectors out of each of these two sentences. Resultant speed just means that is the magnitude, and the direction we'll use inverse tangent. So let's talk about the boats moving here. Okay, so it says boat is traveling west at 25 miles per hour. So let's call that vector B. Let's get it into component form. So how can we get that 25 miles per hour traveling west into component form, horizontal and vertical component? Good. So good. So west is left, right? West is left. That's negative 25. That's horizontal movement. If you're traveling west, there's no vertical component, so it's just going to be 0. Okay. Current is moving south at 3 miles per hour. Let's create a vector C out of that. What's the component form for the current? Good. It's not left or right. No movement there. All this is south. So south is negative 3. Okay. What is the boat's resultant speed? Okay. Let's create the resultant vector. Resultant is where we add the two vectors together, right? Vectors B plus vector C. So negative 25 plus 0, 0 minus 3, or 0 plus negative 3. Okay, so this is the resulting vector that's going to it's going to cause the true direction of the boat's movement. Okay, so from here it says, what's the resultant speed? Think of speed as magnitude. So that's just Pythagorean theorem for my vector. Again, you can leave the negative out if you like. (25 squared plus 9). Sorry. Yeah, 25 squared plus 9. So it's root 634, which is around 25.18 miles per hour. Okay. Direction. Which quadrant is this going to be in? Third quadrant, right? So whatever angle we get using tangent, we got to add 180 to it. Remember, tangent theta is b over a. Inverse tangents. Make sure you're in degree mode. I got 6.84 degrees, but what needs to happen with that? Yeah, 180. Yeah, I think this is the most challenging part, but once you can build your vectors and you can kind of interpret those words in terms of, oh, that's just speed, oh, that's just degrees, or that's just angle measure. Okay. Let's see if we can squeeze in number 13 as well. Alvin pulls a sled through the snow with a force of 50 newtons. Angle 35 degrees. Find the magnitude of the force. Actually, let me come back to this one here. The wording here. Okay, yeah. Let me come back to this one. Okay, sorry. Let's do number 9 here. It says find the component form of vector v given the following. So if you're given the magnitude and the angle measure, then all you do is involve. You can draw a triangle, or you can just use the formula that looks like this. Okay, it's the magnitude times cosine of theta, and then the magnitude times sine of theta. This will give you your horizontal component. This will give you a vertical component. Okay, we started the quiz review. I'll check your review worksheets tomorrow. Okay, so we'll pick this up tomorrow. If you want to get a head start looking through the quiz review, you can, but I think tomorrow we should be able to get through it. Do additional problems if we have time, and then Wednesday quiz. Yep, thanks.